This video is on quadratics review. We're going to be looking at solving quadratics. There are four main ways mathematically to solve quadratics. There's factoring, solve by completing the square, solve by using the quadratic formula, and solve by taking square roots. Because it's telling us the exact method to use, we must use that method. If it just says to solve the quadratic, you can use any method you would like. So, not all quadratics are solvable by factoring or taking roots, but every quadratic is solvable by completing the square and quadratic formula. Let's look at solve by factoring. We need to factor the quadratic first. So when you factor quadratics, you always look for your GCF. You look at your smallest number to see if every number in that problem can be divided by it. The smallest number is 7. So to determine if it's your GCF, we do 35 divided by 7. That works. And we also do 42 divided by 7, which also works. So our GCF so far is 7. Then you look for any letters that could possibly be common to all of them. We have a V, and no V. So since the 42 does not have a V, our GCF is just the 7. When you're solving by factoring, you factor out that GCF of 7 on the outside of the parentheses, and we divide everything. So 7v squared divided by 7 is just v squared. 35v divided by 7 was 5v, so plus 5v. And then 42 divided by 7 was that 6. We're going to have minus 6 set equal to 0. We continue to have it equal to 0. When you solve by factoring or quadratic formula, it must be equal to 0. So factoring is set equal to 0 already. Now we need to factor the inside the parentheses. So we have the 7 on the outside. We want to have two sets of parentheses. It's going to be equal to 0. So we know that going back to factoring, the insides, the very beginning, need to multiply to give us v squared. So the only thing that will happen for that is v times v. Then we need to know the numbers that will multiply to 6 for the last part. So I'm going to list them out over here. We have 1 and 6, but we also have 2 and 3. So I want to plug these numbers in. So this is the factoring by guess and check. This is just, again, a recap of this. I'm going to plug the 2 and the 3 into here, and then I'm going to check to see if this will work. So I'm going to multiply inside and the outsides, so that'll give me the 2v and 3v. I'm going to get a positive 5v, and if these are both positive, that'll give me the positive 5v. So if I do positive 2 times a positive 3, that will give me a positive 6, which is not what we want. So these are bad. It's not the 2 and the 3. So I'm going to erase the 2 and the 3, and I'm going to instead put the 1 and the 6. This is why we use pencil on this, because we are checking to see what happens. So I would have 1v and 6v, and I want to get a positive 5. So I can do 6 minus 1, so that'll give me a 5. So if I have a negative 1 and a positive 6, so that's 6 minus 1 gives me the 5. And then 6 times negative 1 gives me the negative 6. So that one works. So I have that negative 1 and that positive 6 in here. So this is factored. But it says to solve by factoring. When it says to solve, that means I have to have an equals in the end. I have to have an actual equals. So that's an x equals, or whatever your variable is. You do not stop. So we look to see where the letters are located. This 7 does not have a letter on it, so we don't need to worry about it. The first set of parentheses has a letter with it. So we set that equal to 0. So that v minus 1 needs to be equal to 0. Then the other v is with that plus 6, so we have v plus 6 is equal to 0. Now we solve. We add 1 to the other side, so we'll have v is equal to 1. We're going to subtract 6 from the other side, so v is equal to negative 6. Please remember that when you're solving, you're really just finding the x-intercepts of the function. So this was an intercept form. All I found were the x-intercepts. I found my m was really a positive 1, and my n would be that negative 6. So I could graph that. But our answers are v equals 1 and v equals negative 6 because we are solving by factoring. The next example asks us to solve by completing the square. Solving by completing the square is a little easier than just completing the square by putting it into vertex form. Solving by completing the square, we want our a value to be 1. It makes it much, much easier. So we're going to divide everything by that original a value. So everything is going to be divided by that positive 2. We'll end up having 0 equals positive x squared minus 4x plus 3. Now we're going to go and subtract the 3 to the other side, just like we would normally do with completing the square. So we'll end up having 3 equals negative 3 equals x squared minus 4x. This is when we complete the square by doing half of b and squaring it. So I'm going to put it off to the side. Half of negative 4 is our b term, so we're going to do half of that divided by 2, and we're going to square it. Negative 4 divided by 2 is negative 2. Squared is going to be a positive 4. So we're actually going to add that 4 to both sides. So we're going to put plus 4 here, and then we're going to plus 4 over here. 4 minus 3 is 1 equals, since we have added the 4 over here, we have created a perfect square trinomial. That means that we can factor this to become a perfect square into a binomial. We take the square root of the first term and the last term. So square root of x squared is x. The square root of 4 is 2. And then we have to use the middle term, the sign, so that'll become a minus. Now from here, we just solve for x. We use SADMEP. So there's nothing to add or subtract on the outside of the parentheses because we cannot touch the inside yet because that's part of the p. So remember, it's SADMEP, or PEMDAS backwards. So in order to even get inside the parentheses, we have to get rid of the square. So undoing a square, doing the inverse of that, is square rooting it. So we're going to take the square root of both sides. And remember, when you take the square root of a value, so the square root of this 1, you have to put that plus or minus in front of it. So the square root of 1 is just 1, is equal to. Now you have the square root of something squared, which will cancel each other out. So it'll just be x minus 2 on this side. Now you actually have 2 parts of an answer. We really have that positive 1. So we really have positive 1 is equal to x minus 2. But we also have that negative 1 is equal to x minus 2. So when we solve this, we're still going to add 2 to both sides. But we're adding it to both the positive 1 and also that negative 1. So this first one, if I add 2 to a positive 1, so 1 plus 2 is 3. So x is equal to a 3. And if I add 2 to this negative 1, so it's really 2 minus 1, x is equal to 1. So x is equal to 1. So again, we found our x-intercepts by completing the square, but we did not have to put it into vertex form. The next example is solved by quadratic formula. The quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. You're going to be plugging in the numbers for a, b, and c. So our a value, b value, and c value we need to find. But first, it needs to be equal to 0, because if it's not equal to 0, it is not in standard form. So we're going to rewrite this as a positive 2x squared plus 8x, but then we have to add that 5 to the other side, so we have plus 5 is equal to 0. and it does need to be in the standard form. So we have ax squared bx c. It needs to be in that order. Now our a value will be 2, our b value is 8, and our c value is 5. Please make sure you do not put the letters, the x, with the 2 and the 8. Okay? A, b, and c are just numbers. So if we plug them in, we're going to put parentheses everywhere we see a letter. So I'm going to do that first, actually. I'm going to put x equals negative b is the letter, so I'm going to put parentheses, plus or minus the square root of b, so I'm putting parentheses, squared, minus 4a is a letter, so I'm putting parentheses, c is a letter, so I'm putting parentheses, all over 2a is a letter, so I'm putting parentheses. Now I'm just going to put in the numbers. So it was negative b, my b value is 8, so I'm going to put 8 in that parentheses. Then we have plus or minus square root of b squared minus 4a c all over 2a. I just plug in the numbers. Now I'm going to simplify this. So negative times 8 is negative 8. So I have x equals negative 8 plus or minus the square root of. I'm going to go ahead and figure out what that inside is. That's called the discriminant. The discriminant tells you how many solutions you're going to have and if they're going to be real or imaginary. So I'm just going to type inside, the inside, not the square root symbol. So parentheses 8 parentheses squared minus 4 parentheses 2 parentheses 5 close parentheses. Make sure that you put parentheses on every single letter. This gives me 24, so the discriminant is 24. All over 2 times 2 is 4. Now, because 24 is positive, we're going to have 2 real answers. But because it is not a perfect square, these answers are going to stay with a radical. They're going to be irrational numbers. I need to simplify the square root of 24. To simplify the square root of 24, you find your perfect square that goes into 24, your largest perfect square. So if you remember your largest perfect squares, or your perfect squares, you go 1, 9, 16, 25. Well, 25 is already too large. So the next one was the 16. 24 divided by 16 does not work. It gives you a decimal. We don't want that. Then the other one, the next one was 9. 24 divided by 9 also gives you a decimal. Next one was 4. 24 divided by 4. That one is good. The reason we find that is because this 4 will simplify down to, the square root of 4 is 2. So this becomes negative 8 plus or minus. It's really the square root of 4 and the square root of 6. The square root of 4 is 2. Then we still have the square root of 6. So just to remind you, if I type in the square root of 24, I'm going to get a decimal. If I type in 2 square root of 6, I get the same decimal. That means that this is the simplified version of the square root of 24. And it is still all over 4. Now we want to simplify this as much as possible. We'll have x equals. These can actually be separated into 2 fractions. So the 8 is being divided by the 4, but so is the 2. The square root of 6 has to stay because that's irrational. But the 8 and the 4 will simplify first, but you also have to simplify the 2 and the 4. So we have negative 8 divided by 4 is just a negative 2. Then we have plus or minus. 2 divided by 4 is 1/2, so it's just 1 over 2. And that square root of 6 remains on the numerator with that 1, so it's just 1 square root of 6 over 2. Now, it is no longer all over 2 because negative 2 came from the negative 8 divided by 4. We do not put it all over 2 any longer. So this is our final answer. These are, you have 2 answers. They are real. but they are irrational because of that square root of 6 remains. The last one of the solving quadratics is solving by taking roots. This is just a basic solve for the variable. So when we're solving for the variable, again, we're gonna use PEMDAS backwards, which is that SAD method. That's just solving. So we're gonna add and subtract away from this from the n. That n is what we're solving for. That n is what we're solving for. So we have to get everything away from that n. So we add and subtract away first. The 5 is multiplied to it, so we don't touch it yet. The 2 is an exponent, so we can't touch it yet. But the 10 is separated from it, so we can move that to the other side. That's a negative 10 right now, so we add 10. We're going to add 10 to both sides. We'll have negative 5n squared is equal to negative 330 plus 10 is negative 320. We still want to solve for this n. So we have a negative 5 and a 2. The negative 5 is multiplied, the 2 is the exponent, so we have to do the multiplication part first. So to undo that multiplication of negative 5, we divide by negative 5 on both sides. So we'll have n squared is equal to negative 320 divided by negative 5 is equal to a positive 64. We are still trying to solve for that n. The only thing left on it is that squared, which is the exponent. So to undo a square, you square root both sides. Then you'll end up with n equals, because the square root of n squared is n equals. When you take the square root of a value, you have to put the plus or minus. The square root of 64 is 8. So our answer is n equals plus or minus 8. You can separate them as saying n is equal to a positive 8 and n is equal to a negative 8. Solving by taking roots is just a basic solving equation. So just solve for the variable as a normal equation.